All right, peeps. We're going to talk about Unit 10. And this is a super long lesson, 10.1 is. And so I've kind of already filled out the notes, and I'm going to walk through them just for the sake of keeping the video from being an hour and a half long. So, what we are talking about in Chapter 10, sorry, my point to that was there are going to be times when you might want to pause and write some stuff down and then play it and listen to me talk about it. Because if you're trying to do both, I think you're going to get overwhelmed. So as I move the screen or switch sheets, just pause it, write stuff down, and then listen to what I'm saying about it. Or watch it more than once, too. That's probably a really good idea. Anyways, back to Chapter 10. What we're talking about is doing all the same stuff we've been doing. Tests and confidence intervals for means and proportions. But now we're going to do them with two independent random samples. So now I'm going to pick two separate populations and see if I can find out if there's a difference between the proportion who do this versus the proportion who do that. So, and I'm writing these formulas. I don't know if it's beneficial or not. By the way, 10.1, we're going to do this for proportions. 10.2, we're going to do the exact same thing, but for means. And again, just like we've done before, little details change, but big picture does not. Okay, so and I'm not in love with either of these formulas. I'm going to show you how to do it with your calculator. That would be something I would do even in a normal year. And with this year being cray-cray, I just think this starts to get a little bit out of control with the math. Just the calculation, the computation versus the understanding. And they tend to care more about the understanding. All right, so for a confidence interval, we start with, because I got two samples, we're going to talk about what was the difference between the proportion of males versus females, or freshmen versus sophomores, or Asians versus Hispanics, whatever your populations are. And I'm going to get a sample from each of those guys, and I'm going to go find the proportion of whatever it is I'm going to look at, and then I'm going to subtract them. That is the value you're trying to figure out. Now, I know those samples aren't going to produce a perfect value, so we come and do all the same stuff, plus and minus, margin of error, gets still Z star, absolutely the same way we were doing it in Chapter 8. This standard deviation portion is where I think it gets a little cumbersome, or a lot cumbersome. And essentially, we're just talking about the standard deviation for the proportion of one group combined with the proportion of the other group. That's all it really is. Now, I am going to show you in your formula sheet, you have that formula. For two proportion problems, there she is. Now, I'm going to come back to this rascal in just a minute. But you've got the formula for the standard deviation, just like you had the formula for the standard deviation in a one sample problem. So, that would be our confidence interval. And again, the confidence interval is trying to find the true difference in the proportions. I am not talking about the proportion of males versus the proportion of females. I'm talking about how much more one of those groups is than the other, or how much less one of those groups is than the other. So, moving on. When we do a test, a ho-ha problem, this Z-score formula I think is absolutely silly. I don't think I've ever seen a question that required you to use it. I'm just exposing you to use it. But again, the idea is we're going to find out how big is the difference between those two groups, then use the standard deviation, and theoretically, if I were going to do this by hand, we would go find where does this difference lie on our curve, and we're still doing the exact same stuff. Mark it, shade. If it was two-sided, we'd mark it, shade. So conceptually, same stuff. Mathematically, we're getting kind of overboard, which is why I'm going to kind of rely on the calculator. Okay. And again, pause, write stuff down, watch it twice. This is going to go too fast for you to watch it once and try to keep up with writing everything down. Okay, our assumptions just got more, they're the same, they just got to become more of a pain in the butt. And here's why. I can't just say random sample anymore. I've got to communicate that they are independent random samples. And it's one of those things that they will ding you for if you don't say it. In a 2-sample problem, we have to say independent random samples. And the reason why it's such a big deal is the matched pairs problem we talked about in chapter 9. That looks like a 2-sample problem, but those samples are not independent, so we did matched pairs, which was just all of our 1-sample stuff on the difference. Second, each population is at least 10 times bigger than the sample. That is the same thing, but now I have to check it twice. One for each group. So I got to do the proportion of freshmen is bigger than 10N. I got to do the proportion of sophomores is bigger than 10N. So just the amount of time these take is starting to get overwhelming. Additionally, when I do ANSD, approximate normality in the sampling distribution, I got to check 4 different NPs, NQs, or N1 minus P. 2 for each subgroup that I'm talking about. Ay, mamacita los niños. The reality is these are going to be hats as well. You might want to write that in here for these guys. And I'll show you why in a second. All right. This is one of those times. Oh, sorry, this last thing. And again, this standard deviation formula should look funky to you. It's not a typical one. And it's because we have pooled our proportions. This is not a huge gig. The calculator is going to do it for us automatically. I'm just trying to expose you to it if you randomly got asked a question about the standard error for a ho-ha problem. And again, like I said, I don't believe I've ever seen them ask you to calculate it. So, again, one of those things you can kind of ignore. I don't want to say ignore, but I'm trying to do my job, but I wouldn't put a ton of emphasis on it. Okay, so this is one of those times where I would stop and pause it and just write this stuff down for a minute. And I'll have to move my screen around a little bit. Oh, you got to be kidding me. Okay, sorry, I don't know. I had to pause it. I don't know. I was missing a little bit, but and I don't know how this comes across on your end, if it's big enough or not. I don't really want to shrink it because I want you to be able to see it on your computer or your phone. So I'm just going to kind of scroll through here a little bit. Just hit pause and then write stuff down. But again, our assumptions, I have to include the word independent. You will not get full credit if you didn't do that. 2, I got to talk about both populations being more than 10N. All students at the university, more than 10N. All students at the JC, more than 10N. And then I have to check approximate normality in the sampling distribution. That's my third assumption. And that is NP, N1 minus P, sorry, N1 P1, N1 1 minus P1, and we can call that Q1 if you want. And 2 times P hat 2. And N2 times 1 minus P hat 2. All of those, you got to check them and have them be bigger than 10. The reality with that is these numbers are just our numbers of successes and failures. And since I knew there were 43 university kids, I know that's bigger than 10. 100 minus 43 is 57. That's bigger than 10. There were 90 university or JC students, bigger than 10, and 110 university students, bigger than 10. Okay, again, pause, write that down, rewind, do what you got to do, but I'm trying to keep this under a half hour, which is going to be tough. Okay. And again, the order of this, you've got flexibility. If you wanted to come and do this part of it first, and save assumptions till the end if you have time, that's probably what I would do. But this is the organizing of your information. Please notice I've called this P1 and P2, and I'm going to get into that in a little bit. But in your calculator, when we show you this, they call them P1 and P2. Me personally, I like subscripts that help me distinguish between these two. So you could say P sub JC versus P sub university, or vice versa, sorry, I got them backwards. P sub un versus P sub JC. That's fine, that's okay notation. You don't have to use 1 and 2, but when we go to the calculator, it will say 1 and 2, so you just got to be careful for that. Okay, so now I got to set up my ho and ha. First of all, how do I know it was a ho and ha problem? They gave me an alpha. They told me to test the hypothesis. Okay. So now, our ho and ha in chapter 9 was P equals some number. Or P is less than, greater than, or not equal to some number. But because we're talking about finding out if there's a difference between the proportion of JC versus university students, our ho is going to be P1 equals P2. I'm going to assume they're the same, and I'm going to go gather evidence and see if I can find evidence that they are different. And again, we're just trying to find out if there's difference. They could have stated this problem by saying, we think the proportion of JC students would be higher. Well, then it would be a greater than problem. Now, and I'm going to show you in the next example a little bit better, but once you start dealing with greater than and less than in a 2-sample problem, we've got to be real careful. Because Joe Bob could define P1 to be the proportion of JC students, and P2 to be the proportion of university students, and Mikey could define P1 to do it like I did. And if you do that, and you have a less than or greater than problem, you just got to be careful. And I'll show you better in the next problem, because I'm going to change it. So I have set up ho and ha, and now I have to define the true proportion of students at the university who have taken 1 or more remedial college courses. I mean, give me a break. P2, the true proportion of junior college students who have taken 1 or more remedial college courses. Now, I did this actually accidentally, was going to fix it, but it's the kind of thing I see from you guys a lot. And I'm really not talking about the true proportion of junior college students. That would assume I took a random sample from all junior colleges. And I probably could have been better there at this university. So we should be talking about this junior college's students who have taken 1 or more remedial college courses. So, and communication on these it's feisty. I'm not going to lie. And these are pretty common problems in free response. You're going to have at least one problem from chapters 8, 9, and 10, guaranteed. And it's generally a full free response where we just drop it on you and you got to go. By the way, I can't remember if I told you, but you don't have enough space on your notes to really do all of this well. So if you want to use a separate piece of paper, go ahead. Okay. So again, let me recap. Did assumptions. Summarized my info. Set up my ho and ha. That's all stuff that should be done before you ever go to the calculator. But once I've done that, I'm going to go to my calculator and select, so stat tests, the same place we were going, but I want a 2-prop z-test. That's their shorthand notation for 2-proportion z-test. What they are asking you to plug in is the number of people from the first subgroup who did whatever you're talking about. In this case, 43 university students who had at least one remedial course. The sample size for your first one. Then go do the same thing for the second one. And that's kind of why this notation and this table I think is important. Now, if you notice, they are not asking for any p hats in here. They'll produce them once I run it, but they're not asking for it. So what if I were to give you this information via proportions instead of the number of people? you'd have to convert that proportion to a count. Make sure it's a whole number. If you have to round, round. But your calculator will not let you put in a decimal or a percent into here. It's got to be a count. So, I wanted not equal to in this case. I hit calculate. And this is what it produced for me. It has given me my z-score, my p-value, my p1 hat, my p2 hat. This is actually the pooled standard deviation, which you really don't care about. Sorry, it's not the pooled standard deviation. It's the pooled proportion, aka just throw all pooled means is, and I don't want to spend any time on this. I think I'm probably doing too much as it is. We're going to take both groups and throw them together and talk about just the total proportion of the groups. Anyways, the things I care about are z and p-value. So I still have to name the test using a 2 proportion z-test in my calc. I got this z-score. I got this p-value. I look at that p-value and I'm like, damn, girl, that is gigantic. There is no way I have any evidence. So now I got to go communicate that. Because the p-value is greater than alpha 0.05 or alpha 0.1 or alpha point, whatever alpha you have. We do not have evidence to reject Ho. And therefore I cannot say that I have evidence of a difference. You still got to put it in context again. In the proportion of this university's students who take one or more remedial courses compared to those at this junior college. And again, if you do that problem well, that is real tough to get done in 12, 13 minutes. Not going to lie. Okay, so I'm going to kind of switch gear. That would be a full test, a hypothesis test for a 2 proportion problem. Well, I could also ask separately, usually not a follow-up as well, but theoretically could be. What if you wanted to do this as a confidence interval instead? Well, you're going to go and do all this same stuff. All the same assumptions would have to be checked. I've already checked them, so I didn't redo it. You'd have to still summarize your information. We wouldn't need the ho and the ha because we don't use that for a confidence interval. And so I go into my calculator, into the 2 proportion z interval, and it's really the same stuff. They're asking for x1, n1, p1, or x2, n2, and then they ask you to type in your confidence level. That's it. You would need to report this. I didn't write it down because I'm tired of being here already. It's Sunday. But that is the confidence interval that we've produced. So now I need to interpret it. I'm going to say it again. You would need to say this. My 95% confidence interval is that, and then interpret it. We are 95% confident. Pay attention because this is very confusing in my mind. 95% confident that the true proportion of this university's students who take 1 or more remedial college courses. Okay, this is an ugly one. Essentially, all I did was define my first group. Whoever I plugged into X1 and N1. This is ugly because my confidence interval has negative and positive values in it. Well, what that tells me is, since 0 is in there, somewhere between those numbers is 0, it's possible that there is no difference between these 2 groups, which corresponds to what we did up here. I had a huge p-value. I got no evidence that there's a difference. This would give me the same thing. It's possible there's no difference because 0's in there. It's kind of like the UNR problem where we talked about private school students. If 12 was in your interval, you didn't have evidence. Well, now that I'm dealing with a 2-sample problem, the number we care about is going to be 0. So, in terms of communicating, when there are negatives and positives, it's the hardest one to communicate. We're going to say is between 13.9% less, that's the negative, and 9.9% more than that of this junior college. I probably should have put students in there. Probably wouldn't hurt to say who take more than one. I'm probably being OCD, but I believe that would get you full credit. Again, if I hadn't already done them, I would still need to. I got to show you one more thing. I don't think I showed you this. This becomes important. This is you communicating the direction of your subtraction, aka how you plugged it into your calculator. And if I would have switched these guys and called the JC P1 and the university P2, the answer I would have gotten would have been the same p-value in this case, but the answer I would have gotten would have been negative 0.99, would have been negative 0.099 to positive 0.139. So essentially it's the same interval, it's just the order of the subtraction changes a little bit what your answer might look like. So you do have to be careful for this, and it is something that they will look for. Okay, I'm already 21 and a half minutes in, and here's just two more problems. And I'm not going to go through them as thoroughly. If you have questions about them, or there are things that you notice while you're watching this, just bring them, and we'll go over them next time I see you. But still assumptions. Pause it. Write them down. Same ideas. Still got ho and ha. And again, little details. Males at Reno High. Who do what? Use foul language on a daily basis. Versus proportion of females. So on this ho and ha, I chose to use subscripts just to expose you to it. If you don't like it, don't do it, but you could see it. And that's why it could be a multiple choice question and they could show it. Or you could be looking up the answer to a free response and they're doing that. And I don't want it to freak you out. So again, pause it and write it down. Summarized. Did a 2 proportion z-test. Plugged the data into my calculator. My x, my n, my x, my n. And it cranked out my z-score and my p-value. Please note this is pretty important because you might write 8.18 as your p-value, and it makes me understand you don't know that a p-value is probability. It's got to be less than 1. And in this case, it's way less than 1. I was 6.5 standard deviations away from the mean. I mean, that's essentially convincing. I mean, I'm almost guaranteeing it. I would not see a difference this big if ho was true, if there really was no difference between the proportion of males and females. So again, got to communicate, but in this case, because my p-value was small, less than alpha 01, we have strong evidence to suggest that the true proportion of males at RHS who use foul language daily is different than the true proportion of females at RHS who use foul language on the daily. Okay. Likewise, they came down here and made us do another confidence interval. Shouldn't say they, I did. You'd still need to define ho and ha. Sorry, not ho and ha. You'd still need to define, hey, because I didn't do this on the last one. What are your proportions? What is P1 and P2 that you're really talking about? Because I'm using that notation here. So you still have to define what they are. You just don't have a ho and a ha to put them into. Still would need, again, assumptions, summarize. And then, using a 2 proportion Z confidence interval for, I chose to do males minus females. we would need to report this. Now, and it's easy to get confused here, that is not the proportion of males who use foul language. That is not the proportion of females who use foul language. It is the difference in the proportion. So when we communicate this, we would say we are 99% confident that the true proportion of males at RHS who use foul language on the daily is between 30.4% and 63.4% more than the proportion of females. So males are significantly more likely to use foul language on the daily. Yeet. Okay, one thing I do want to show you. I'm almost done. What would happen, and I probably should have done this problem this way first, but whatever. And when I say this way, what would happen if I went into this problem thinking that males were more likely to use foul language? Well, then you're going to have P sub M is greater than P sub F. Well, when I go plug my stuff in, I plugged it in. Notice I chose less than. And that is a mistake in this case because I plugged in the males first and the females second. And it produced a p-value of essentially 1 and... No, I didn't. Of essentially 1, which is completely wrong. And it's wrong because I chose this incorrectly. My point is, that could be right if I had plugged my data in opposite. If I'd have plugged the females in first into my 1s and the males into my 2s, then this would be the correct alternative. When I did it correctly, by selecting greater than because of the way I plugged it in, I ended up with p-value am I getting a different number? I shouldn't have a different p-value. Oh, yeah, I should, because I did not equal to on the first one. Are you with me? On the first one, I did not equal to, so we had to double this. Sorry, I'm pointing with my finger and you can't see it. We had to double this. That's why the p-value is different. Versus if I only did one-sided, I wouldn't have to double it. But anyways, more importantly is, if it's one-sided, you need to be real careful about who you're putting in first and what is your alternative that you're trying to show. Okay, 28 minutes is, and that's me rambling. You likely would need to watch this twice, unless you're a full-on gangster. Just so you know, we're going to do this Tuesday and Wednesday. Sorry, we're going to go over this Tuesday and Wednesday, meaning you'll watch it Monday and Tuesday. And then you'll have another video for means. And we're just grinding. So you got 1 day of video and 1 day of grinding on the homework. Then another day of video and another day of grinding on the homework. And then I'll talk to you more about what my plan is for review / chapter 11. Okay. You guys are awesome. 3 more weeks. We can do this. Let's just get it done. Bye, guys.